AP Calculus, Unit 7, Day 59, Part 2. Antidifferentiation by U substitution. So we're going to look at the same pattern we just did. So in each of the 8 examples above, the g prime of x, or license to integrate, existed in the integrand of f prime of g of x times g prime of x dx. Or g prime of x was attainable by multiplying by a constant. So a couple times we had to do that. And again, this is the license to integrate. And I drew up the whole thing here because this is what we're trying to take the antiderivative, taking the integral and go backwards. Okay, and there were times where it wasn't exact, but we could just multiply by a constant, so that was good. Okay, the g prime of x does not always exist, and there are times when it is not attainable by multiplication of a constant. Consider the example below. So let's do this. Okay, so what's the inner function? G of x, that's going to be the 2x minus 1. Okay, what is the derivative of that? G prime of x, that's 2. Okay, that's the license to integrate. And is g prime of x part of the integrand? I have an x, but I don't have a 2, so no, it's not. Is g prime of x attainable by multiplying the integrand 2 by a constant? No. Okay, so because in order to get x, I would have to get that, start with 2. What would I have to multiply x by? I'd have to multiply by 2 over x. Okay, so that's not going to help me. Okay, so in this case, we must find the antiderivative by a method known as U substitution. So here's how it's going to work. Okay, so I rewrote the problem. Integral of x times 2x minus 1 all cubed times dx. So let's let u equal the inner function. Okay, so I've been able to identify the inner function g of x. So we're going to say u equals 2x minus 1. And what I want to do is I want to find u, and then later on x. We'll do that. Let's jump to that right now. So find expression for x in terms of u. So it was u equals 2x minus 1. And you can do them. You don't have to do it 1, 2, 3. Some people like to do it this way. So now I'm going to add 1 to both sides. So u plus 1 equals 2x. Now I'm going to divide both sides by 2. So u plus 1 divided by 2 equals x. Okay, so I know what x is. I know what u is. All right, now find du and solve for dx. How do I do that? Well, I know what u is. So let's take the derivative of u. Derivative of u is 1, but it was the derivative of u with respect to x. What's the derivative of 2x? That's going to be 2, and the derivative of negative 1 is a constant. So we just took the derivative of this function right here, with respect to x. Well, but I want to find what du is. So that's 1 du dx. Can I multiply both sides by dx? I can. So then I know du equals 2 dx. That's good. And then now, what if I want to solve this for dx? So just like we're trying to find, so I divide both sides by 2. Or multiply by half. 1 half du. Okay, so I know what u is, I know what x is, I know what du is, I know what dx is. Now we're going to try to go and write as many things in terms of u and du from the original function. So what's x? X is u plus 1 over 2, and I'm going to just rewrite that as 1 half u plus 1. Sorry about that. What is 2x minus 1? That is u, and it's going to be u to the third. And let's do, what's dx? Okay, that's 1 half du. So now I'm just going to simplify this. 1 half and 1 half is 1 to the fourth. And let's go through right now and do u to the third times u is u to the fourth. plus u to the third du. Okay, now this looks a lot easier to be able to find the integral for than what we started with, because we didn't have rules for that. So now what do we do here? Let's just go through. Let's take the constant out. And I get u to the fourth plus u to the third du. And again, we know when I have integral of a sum, it's the sum of two integrals. The constant's just going to slide down. So let me make this page a little bit bigger. So we're going to get 1/4 u to the fourth. What do I do? How do I do the integral? Okay, just add 1 to the exponent and divide by that same number. Same thing here. Add 1 and divide. It was an indefinite integral, so I got to make sure I add my constant. So we get our constant. I don't want my final answer in terms of u. So the first thing I'm going to do, though, is I'm going to distribute that 1/4. So this is really 1/4 times 1/5. So I get 1/20 u to the fifth. 1/4 times 1/4 is 1/16 u to the fourth. And really that constant should have been in that parentheses, because the 1/4 just dropped down. So 1/4 times a constant, still a constant. You can just leave it as a c. Okay, but now every place I see a u, what did we say that was equal to? 2x minus 1. So now our final answer is going to be 1/20, 2x minus 1 to the fifth, plus 1/16, 2x minus 1 to the fourth, plus c. Okay, and it looks very, very difficult to how you got there, but this is a pattern that we can do over and over again. Okay, let's look at another couple examples, and you'll be able to practice on home.